The wave generator is made up of a few different parts. So first there's the base, which connects to the base of our wave pool overall. Then there's this structure on the side which holds the servo. This is a standard hobby servo, nothing fancy, nothing special, just kind of what you can get off the shelf. The side structure also holds on this 4-bar linkage, and this 4-bar linkage is there to make sure that the foam only moves up and down. Of course, there is a little bit of an arc, but the linkage is long enough that any effects of that are mitigated. Additionally, there's another linkage on the servo itself, which amplifies the speed, the linear speed of the wave generator, but also decreases the force. But it turns out we don't need too much force in order to create these waves. Everything is rather sturdy in order to ensure that foam only moves up and down and doesn't create any weird effects. Kind of the part that comes in contact with the water is acrylic, because acrylic does well with water, while MDF, which is much cheaper, which we made the rest of our actuator out of, is not in contact with the water. And all of our pivots, there are 10 of them, have little bushings with dowel pins to make sure that the friction is relatively low in the system. The foam is shop botted out of kind of standard pink foam housing insulation, and it does have a contour on it, a 3D contour, which makes a full kind of circle with all of the foam pieces around.
All of the wave generators can be controlled independently from one another, so they are set up in a circle that goes around the wave pool, specifically so we can control the wave pool at the boundary condition. Although they're independently controlled, they're controlled by a single servo shield on an Arduino, so we're able to run them all in a single Arduino script, which is nice because then we can change the frequency of each of them and the delay between them in a single script. This is quite a large system. There's 16 servos that we have to power, which takes 5 volts and 10 amps to power all of them together. The base was shop botted, so you can see we made everything equidistant from each other, because in order to put our wave generators together, we have screws on the bottom, so we have indents. We needed to make sure that the base was able to come apart easily, so we could move the wave pool around, but we also have it so we can screw it together so it won't come apart when it's in use. The foam pieces form a closed circle and they don't ever leave the water surface, which means that it pretty much creates an entirely closed boundary condition around the edge of the pool. We were initially worried about our wave pool is not actually a circle because it's a kiddie pool, so the boundary is kind of wavy. But because our wave generators form this boundary, we don't have to worry about the boundary that exceeds the wave generators.
masterpiece. You should be rolling me, you should be rolling me. You're a real life fantasy, you're a real life fantasy. But you're moving so carefully, let's start living dangerously. Time